Hello and welcome to session 5, the R part of Data 5070, Statistical Software Packages for Applied Data Analytics. I'm your TA Ayush, and this video, we're going to be going over normalizing data and 3 types of clustering methods, the k-means, hierarchical clustering, and k-meteoids, or PAM, which stands for partitioning around meteoids, clustering methods. Right, so let's get started with the R part. So for this video, we're going to need these 4 modules: dplyr, ggplot2, cluster, and factor extra. And for the data, we'll be using USA arrests. You could get it by just simply calling out USA arrests, as the data set is available in R itself. We run that, we can see the head of the data. We can see the data set itself too. We have all 50 states in the US. We have murder, assault, urban population, and rate, 4 variables that we would be looking at. So now that you get a sense of your data, we can get the structure as well. So we see murder, integer, 2 numericals. Great. So for the first step of doing any cluster analysis would be to normalizing the data or scaling the data. So we're going to normalize. And scaling data in RStudio, it's quite simple. I'm just going to go to scaled data, create a new object, and call out the scale function. Right, so now we have a new variable, and you can see compared to the data, now what the scale function has done is it's given equal weights to every variable. So now that we cluster, we can form more cleaner clusters rather than visualizing this data set. And I believe the scale function is derived by something along with taking the averages and subtracting the standard deviation. And that's how we scale the data sets. There are also other methods you could use, like using the z-scores and doing manual standardization yourself as well. So before we run any models, we're going to find the optimal number of clusters. And to find the optimal number of clusters, we're going to be using the factor extra library. So I'm going to set seed and use fwiz. And bclust. This is used for the cluster function. So we're going to call out our scaled data here. Use k-means. And method would be silhouette. Right. So according to the silhouette graph over here, we could always think about it like an elbow, like other methods. But according to this, 2 number of clusters is the optimal number. So hence we're going to be using 2 clusters. And we can also run Yeah, let's start at 20. Why not? So now here we run our k-means cluster analysis. By just simply calling out the k-means function, our scaled data, and the number of clusters that we are looking for. Here we have our cluster means and the clustering vectors. And we can now form our clusters and visualize this by using the fwiz cluster function, which is fwiz underscore cluster, calling out our data that we going to use. And we also call out the KMRES, the k-means model that we've just created. And there are some additional and there we go. There's some additional functions you can run, such as the palette, the theme, etc. But I'm just going to be using this. So as you can see, we just call out the fwiz cluster function, and now we have our k-means cluster, specifically two clusters in this plot. But if you wish to go 3, you can just call out 3, and now we have 3 clusters. And just to repeat, it is due to this how I got my number of clusters, optimal number of clusters, that is. And lucky for us, there is an easier way to run this using the PAM function. And as I told you that before, PAM is the partitioning around meteoroids, which was introduced by Kaufman and Rousseau in 1990. It is less sensitive to outliers compared to k-means. So, and running this is quite simple, just like the k-means function. We would make a new one called PAM1, calling PAM function as scaled data, and 2 number of clusters. That is run. You can also look at the summary using PAM1. It's very similar to k-means cluster. And we can use the fwiz again, and this time just call out the PAM function that we've just created. So here's the cluster plot based on the PAM function. And if you want to compare the results between the PAM and the k-means algorithm, you could just save them in a data frame and do your analysis further. So what I will be doing is just calling out my data frame and create a new column called cluster, which will simply have the number of the cluster of which every state lies in. So if Georgia is in cluster 1, I'm going to assume all of this is all going to be in the cluster 1, cluster 2. So I'm going to call a new data frame, use the cbind function. USA Just call out my data. And I want a new variable called cluster, which is the name of the cluster in my PAM function. Or you could also do this for your k-means function. So now if you look at a data cluster, something didn't go right over here. I need to double check. I'm going to try a new line of code here to see if that works any better. Yep, that worked perfect. So now we can see we have the states, the variables, and what cluster each state is in. And to save this, we could just do write.csv and save this data frame to your file. And we can call it cluster1.csv. So this data frame could be saved in a CSV file. And if you run that, and if I look at my folder, yep, we can see we have it over there. And remember to get your working directory and pointing the working directory to where you want it saved. So we just looked at two clustering methods. Last one, we can look at hierarchical clustering. And the intuition behind hierarchical clustering is that instead of forming it into clusters and a scatter plot, it uses the partitioning approach to identify different groups in the dataset. And it does not require you to specify the number of clusters that are to be generated. But it's still nice to give it some sort of a number for your clusters or your partitions. So we're going to do a rest one. I'm using a pipe function. And you can also use this pipe function for every data set that we have used till now. So I'm just going to copy. Right. So what this function does is it tells you that, hey, I want the USA data set and I want you to scale it using Euclidean distance and making a hierarchical cluster on it with the word.d2 method. So I'm going to run this, and to visualize this, I can give you all the codes are going to be provided for you. So for visualizing this, we use this code here, which tells that we are partitioning it into 4 different sections. And these are just my preferences for the colors and stuff, but you can obviously just remove all this or all this too. So if you want, you can just run this instead, and the results are going to be the same. So here we can see how the 50 states have been divided into 4 groups of hierarchical clusters. And while you're working on the data set provided to you, we could obviously look at the optimal number of clusters from over here. But it is also nice if you want to look at different number of clusters and analyze your results. So for example, if I want to run a k-means 4 times, so I call out the k-means function, call it k2, two centers start at 25, can run all this. So I just created 4 k-means, and I'm gonna plot them individually first. So plot 1 is going to be first the same cluster function that we've been using, calling out the new k-means models that we've created. We want the points, use the data, and this is the title. I can run all this. Now we can call in the grid extra library. And use the arrange function. So I've got my first plot, my second plot, my third plot, and my fourth plot. The number of rows I want is, I think 2 rows should be fine. Right, so you can see all the results from over here. And the thing about the clustering methods is there's no right or wrong answers around how many clusters you should use. So I highly suggest that you experiment with the number of clusters and try to discuss if 1, 2, or possibly all of these clusters can be used. And that is all I have for now. If you have any questions, please feel free to email me. All the code for this session and the video and the PowerPoints are going to be uploaded. Thank you very much. Bye-bye.